Okay, on your desk, you should have your homework, which was page 97, 98, and an ink pen. I am going to pull up the answers for 1 through 7. Okay, everybody listen, 1 through 7. That is the whole front side and the back, the number 1 on the back, first one on the back. If you missed them, I want you to first write down the correct answer, but then see if you can figure out why did you miss it. If you have the right math problem and the wrong answer, that probably means your multiplication was wrong. So go out to the side and try and rework those math problems to see if you can get to the right answer. If you cannot figure out why you missed 1 through 7, raise your hand and I will come to you. If you get 1 through 7, check, just sit quietly till we're ready to go on. Okay? Now, on here, I did work out 3 and 4. You maybe worked them out differently, but if it's in a green box, so like on number 3, it asked for this answer as it is it as an expression and the value. So on 4 and 3, you should have 2 different answers. Okay, so take a few minutes and check these. If you can't figure out what you did wrong, raise your hand after you have tried to rework it. Okay, number 7, let's talk about it for a second. I have up here that the answers are 10 squared and 100 pounds. What in the problem told me that I needed both of those answers? Because walking around, I saw some people had 10 squared, some people only had 100 pounds. If this was a test and you only had one or the other, I would have to take off some points. So Kylie, what in the problem tells me we would have to have both of those?
It says write 10 times 10 using an exponent and then find the value of the
Okay, so it tells me to write 10 times 10 using an exponent. So here is where I answered that question. Okay, 10 squared. And then it asks me the weight of the dog. Okay, and do we say, my dog weighs 10 squared pounds? No, we don't speak in exponents. So we have to evaluate it or find the value of that, which means multiply it out and get 100. Okay, any questions, any other questions over 1 through 7? Raise your hand if you made a mathematical error, meaning you multiplied incorrectly somewhere. Okay, that's pretty common. I saw lots of mistakes on prime factorization, 5 and 6. Remember, that's where you break it down into 2 numbers that multiply to get that, and you just keep breaking it down until they're all prime. Yes, ma'am?
Whenever I did number 6, I just did, when I had to break it down from the tree, I just did when it did the multiplication, and I didn't do exponents.
Okay. Okay, which is an easy fix. Okay, number 8. You guys had to do the first part of 8 together. I will read the problem. Number 8 says, the area of San Bernardino County, California, the largest county in the U.S., is about 3 to the 9th square miles. So it is telling me, hey guys, set your pens down if you're not using them. Just set them down if you're not using them. It says, the area is 3 to the 9th square miles. So yesterday, a lot of people were asking, do I have to find the area? Technically, they gave us the area. But do we speak in exponents? No, they said the area is about 3 to the 9th square miles. Then they went on to ask us to write this as an expression. How can I write 3 to the 9th power as an expression, Drake?
19,683.
Nope, that's not an expression. Aubrey?
3 times 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 3
Yeah.
times 3.
Yes, 3 times itself 9 times. Why do we not like this math problem if it asks me to do what? Waylon, what question do I not want them to ask?
To multiply that.
Will they say, then multiply that, or what question will they ask?
Find the value.
Find the value. We don't want to see the word value in this problem. Do we see the word value in this problem? Is it there?
No.
No, but what word is there that means the exact same thing, Callie?
What is the area?
Okay, yeah, it asks me for the area. How do I know that it wants me to multiply those out, Waylon?
Because area is the outside and that means to multiply.
Okay, that is true, but it's because do we speak in exponents? No, so if they ask me the area of something, that means they want me to go ahead and find this value. Raise your hand if you used your resources and you used the front side to help you here. How could the front side help us here? Anybody use those resources, Callie?
When 3 to the 7th power.
Yeah, on the front, you, if you did it correctly, already figured out that 3 to the 7th power was what? 2,187. What do we have left?
2. 9.
Times 9. You could have just done that problem. Is that cheating? No, if you worked it out on front by yourself without a calculator, and now you do 2,187 times 9 without a calculator, did you do all of the math that you needed to do?
Yes.
Yes. Raise your hand if you didn't even catch that you just multiplied a lot of 3s 2 different times. That's fine. If you multiplied them correctly both times, and you could have grouped them lots of different ways, okay? You could have grouped them lots of different ways, but it's 19,683 square miles. Now, if you missed that answer, I'm not too terribly worried about you, but you should have 9 3s right there. So I'm not going to give you time to rework this one if you missed it, just because there's lots of places you could have messed up. Okay, as long as you knew that you had to take 3 times itself 9 times, I'm not too worried about you. Okay, number 9 was vocabulary, and 10. Yep, you'll have to watch this video because we are doing a whole bunch of new stuff today. Okay, number 9 says numbers expressed using exponents are called what? Grayson?
A power.
Powers. Good job. So for number 9, you should have powers written. Oops, we skipped the second number 8. I'll go back to it. Number 10. The exponent indicates how many times the blank is used as a factor. Emma? We don't call it the number, though. It is a number, but there's lots of numbers, so we have to be specific. What do we call that number? The base. Okay, and again, numbers just not specific enough. That's like when I see a bunch of hands, if I say girl, does that really narrow down who I'm talking about? No, so that's like calling the base a number. It is a number, but let's call it by its specific name. We're going to do number 11, and then we'll go back to the second part of 8. A 100-pound person on Earth would weigh about 4 times 4 times 4 pounds on Jupiter. Do we talk like that, Cam? No. It says evaluate the expression. What does that mean, Cam? If it says evaluate the expression. Zach, will you pull the door shut, please? What does it mean, Cam, if I have to evaluate it? Not round. Emma? Yeah, like do the math, get an answer. So in this one, we had to take 4 times 4 times 4 times 4. Most of you probably grouped 2 4s and got 16. 16 times 16 times 16 is 256. Why for this, whatever it is, just leave it. Why for this are we done? There is a second part, but why does it not even really, we should still look at it and make sure. Aubrey?
Because that's the first answer.
Yeah, if I'm looking at the first answers, there's only one of them that is 256, and it is C. C says 256 colon 512. So the second part said, how much would a 200-pound person weigh? We just found that a 100-pound person on Earth would weigh 256 on Jupiter, and it's wanting me to find a 200-pound person. So how can I check and make sure my math is correct? How did they get from 256 to 512, Noelle?
256 times 2?
Yeah, they doubled it because how do you get from 100 pounds to 200 pounds? You double it, okay? So again, that's one where multiple choice sometimes can be our friend. Now, if there were two of them that had 256 as the first answer, we would have had to work that one out to find the second one, but that was the only option. So as long as you got 256, you knew the other one had to be 512. Okay, let's go back to number 8, because I said we would. Part 2 says, is 3 cubed plus 3 cubed plus 3 cubed the same as 3 to the 9th power? Now let's not talk values, let's just talk math. What is the difference? Well, let's go ahead and expand that out. Who thinks they can expand that problem out? Grayson?
Make 3 to the power 3 to 3 threes.
Okay, 3 times 3 times 3.
And do that to the other one.
Okay, expand all of those out. What am I missing in my expression right now? Who can answer that question? Waylon?
The multiplication signs?
They're multiplication signs in part A. What are they in this one?
The additions.
Addition signs. So now we've identified the difference. In part A, when I'm doing it properly, when I'm doing 3 to the 9th power, it's 3 times 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 3. 2 of our multiplication signs were replaced with what? Addition signs. So knowing what we know about addition and multiplication, can we just pull out a multiplication sign and put in an addition sign and get the same answer?
No.
Why not?
Because if you multiply something, you take the number and you take the other number that it's multiplied by, and you do that number as many times.
Okay.
You add that number as many times.
So are we all agreeing that multiplying and adding are not the same operation? So do you think we will get the same answer if we found the value of both of these?
Yes. Yes.
Raise your hand if you think yes. Raise your hand if you think no. Okay, it is no, because adding and multiplying are not the same thing. We'll prove it in just a second. But I want you to write no, because adding, oops, that's a D. Adding and multiplying are two different operations. Now we're going to prove it. What is 3 cubed? 3 times 3 times 3. Waylon? 27. So this second one, part B, is saying 27 plus 27 plus 27. I'm going to go ahead and do the math for you. It's 81. Is 81 equal to 19,683? No, they're not even close. When we use exponents, the numbers get very large very quickly. Okay, because you're multiplying it by itself. So it's called exponential growth. You'll learn about that in 8th grade. But anytime exponents are involved, the number grows much more quickly than it would if you're just adding. Okay? Questions on any of that? Okay, set that paper aside. Pull to the top. On your desk, you have a piece of paper that says 2.4 multiplication pattern notes. Pull that paper to the top. Put away your pen and just get out a pencil. We're going to go fairly quickly through the first part of the notes because it's review. We're going to slow down at the end a little bit. The top of this notes page should look familiar because you've already done them this year and you did them a lot last year. On example, the first example, who can tell me the important numbers I should be focusing on? Madison?
4 and 5.
Okay, underline 4 and 5. 4 times 5. That is our mental math problem. You should not have to do algorithm on any of these. What is 4 times 5, Madison? 20. I write down my answer. Sophia, what else do I need to add to that?
A 0.
Why do I need to add 1 0? Yes, I want you to physically count it because I've already graded some of these on your weekly worksheet. If you missed them, you didn't put enough zeros or you put too many zeros. Probably because you were rushing, okay? Slow yourself down, count your zeros, make sure you add in that proper number of zeros. Next one, Callie, what's my important numbers?
6 and 3.
What is 6 times 3?
18.
How many zeros do I need to add?
2
2 zeros in my problem, so I add 2 to my answer. And I put in my comma. I want you to take a second and try and finish the next 3. Leave the last one. We'll talk about it. Underline your important facts. Count your zeros. Leave the last one for a second. Okay, for the third one, the fact was 6 times 4 is 24. Why did I have to add 4 zeros to my answer, Drake?
Because there's 4 zeros. 3 behind the 6, 1 behind the 4.
Yeah, because there were 4 zeros in my problem. There were 3 behind the 6 and 1 behind the 4. We find 1 total. For the next one, I'm just going to give you the answer. If you can't figure out why it's this, just raise your hand. So it is 180,000, so it should be an 18 with 4 zeros behind it. Next one is 5 million, so a 5 with 6 zeros behind it. Why do you think I had us take a pause before we do that last one, Drake?
Because there's only 1 0 behind 250 and there's a 2-digit number.
Okay.
So it's a 3-digit number.
So really, is this necessarily a mental math fact?
Oh, no.
Sometimes, for some it may be, for some it may not. If you don't know this mentally, 25 times 2, what could you do? Waylon?
2 times 2 and then 5 times 2?
Well, you could go out to the side and do algorithm or lattice to figure it out. Why should we probably know our 25s though? Sometimes they expect us to know like our 15s, our 12s, and our 25s on this.
Because they're like quarters.
They're like money. They are like quarters. This means you have 2 quarters. Colby, if you have 2 quarters, how many cents do you have? 50. So 25 times 2 is 50. How many zeros do I need to add, Easton T? 2, because there's 1, 2 in my problem, so I need to add 2 to my answer. Okay, so all of that's old news, right? Powers of 10 are actually old news. You've just never heard them referred to as this. They are just powers. Have we already talked about powers?
Yes.
Yeah, they're powers, but all of the powers have a base of 10. They are the most common powers. They're used a lot in science, because if I am measuring from here to the sun, do you agree that would be a really long number if I measured it in just regular standard form? So they use what they call scientific notation, which uses powers of 10 to write those long, ugly numbers in a much easier way. So again, I'm teaching you the foundation of exponents. You're going to add to this for a really long time. I think you talk about scientific notation in 7th and 8th grade. So when we see 10 cubed, how can I write that as a product of the same factor? Emma? 10 times 10 times 10. Do you guys all agree with that? Could they have also asked me to write it as an expression? Yeah, that's the same thing. Common error here. Emma, what do you think a common error is when they're taking 1 times 1 times 1? What do you think a common wrong answer is? 30 or 3. Okay? 1 times 1 times 1 is not 3. What is 1 times itself no matter how many times you multiply it? 1. Underline the 1 times 1 times 1. It's always 1. Anytime you're multiplying a bunch of 1s, it's always 1. How many zeros do I need in my answer? 3. 1, 2, 3. I'm going to go all the way down to 10 to the 0. Caleb, anything to the 0 power is 1. What about 10 to the first power? That's a weird one. Aubrey?
10.
It's just 10. I want you to take a second and fill out the rest of this table. Okay? Under each power, it wants it written as a product of the same factor, which is your expression, and then it wants the value. So I want you to take a minute and fill out the rest of this table. Use our one that we did as an example. So you're doing 10 to the 5th, 10 to the 4th, and 10 to the 7th. Yeah, grab them, the locker right outside the door. There should be some. Focus on this instead of what's that. Once you have your table filled out, look up, see if you agree. Once you have double checked and make sure you agree, I want you to look for patterns. Look for something you notice, because there's actually a trick. When we are doing a powers of 10, and it only works for powers of 10, there is a trick to make our life easier so we can kind of skip the middle step, the writing it out step, the expression step. So I don't want hands up yet. I just want everybody looking at it. Once your table is filled in and you make sure your table is correct, I want you to be thinking about, what do you notice about powers of 10, or what do you think the trick is? Everybody's thinking about it right now because there's some people still writing. We're looking for a trick. A trick that can potentially help me skip the step where I have to write out all of the powers. Okay, who thinks they noticed the trick? Easton T, what do you notice? How many tens there are? So you're looking in this row? Yep, so he says however many tens there are, that's how many zeros there are. He is correct, but the trick is going to help us cut out that step to where we can go from here to here. So you're on the right track, and you are 100% correct. Sophia?
What number the power is how many zeros there?
Okay, the exponent. Does that match the number of zeros?
Yes.
Okay? So she is saying, like, if I look right there, my exponent of 3, are there 3 zeros? Yeah. What do you notice? What else do you notice about all powers of 10? Drake? The top number.
Top tower, base.
So we can't always take 10 times 10 times 10. That will always work. Okay, so if I show you this trick and you're like, I don't like that trick, you don't have to use it. If you know that 10 cubed is 10 times 10 times 10, and 10 times 10 times 10 is 1,000, you don't have to use the trick. Look at the values of all the powers of 10s. What are they all made up of? Ones and zeros. So that's what we're going to write down, part of it. We're going to write that all values start with a 1 and have zeros. Those are the only possible numbers in the value for a power of 10. It has to be a 1 with some zeros. So all values start with a 1 and have zeros. Where did we decide the number of zeros come from? The exponent. The exponent tells how many zeros? Now I'm going to show you this trick on the next few problems. So let's get what we notice written down. I'm going to show you how that can help us. It'll really just shorten our work a little bit. And again, if I show you this and you don't like it, do you have to use it? No, you could always write down 10 times 10 times 10, and I know 1 times 1 times 1 is 1. I have 1, 2, 3 zeros in my problem, so I need 3 in my answer. Okay, does anybody still writing that? Okay, let's look at the bottom 6 problems. How are those different than the ones we did at the top? How are they different than the ones we did at the top? Mila?
Can they have a little number on top of this?
What do we call those little numbers? Exponents. We are multiplying whole numbers by powers of 10. Okay, those top 2 are actually in scientific notation. You don't have to know what that is yet, but that's what that looks like. So to evaluate these or to find the value of them, we break it into steps. All of these will have 2 steps. Underline 10 to the 3rd power. First, we have to figure out the value of 10 to the 3rd power. We could write out 10 times 10 times 10, or we can use our trick. I see a power of 10, so I know my value is going to start with a 1. How many zeros do I need to add behind that 1, Zach? How do I know that it's 3? What did we just write? What tells us how many zeros? The exponent. So circle that exponent. I'm showing the world that, hey, I know that 3 is telling me that I need 1, 2, 3 zeros. We're going to drop down the times 4. Now we have a problem just like we had at the top. Brennan, what's 4 times 1?
1.
4 times 1.
4.
4. And how many zeros do I need behind that answer?
3.
3. I had 3 zeros in my problem, so I need 3 in my answer. Rory, next one. 10 to the 4th is what I'm going to evaluate first. How can I figure that out?
You write down your 1.
Okay, I know it's going to start with a 1.
And then the exponent says 4.
Yeah, the exponent tells me I need 4 zeros behind that. And again, if you don't like that, you can write out 10 times 10 times 10 times 10. 1 times 1 times 1 is 1. You'll count up 4 zeros in the problem. There's 4 in the answer. Easton G, mental math. What's 6 times 1?
6.
How many zeros do I need in my answer?
4.
1, 2, 3, 4. Good job. So put in my comma. I have 60,000. Next one. Audrey, 10 squared. What's its value?
2 times 100.
So what the value means, do the math. 100 because it's a 1 with 2 zeros behind it. Colby, what's 8 times 1? 8. How many zeros do I need behind that? 1, 2, 3. 3. I want you to take a second and try the next 3. Be careful on this one. Be careful there. Take a second, try the next 3. Okay, who can help me with the next one? 700 times 10 to the 4th. Go ahead, Michaela. What do I have to do first? Okay, so I have to evaluate 10 to the 4th. So I bring a 1 down, and then how many? Okay, why do I add 4 zeros? Good job, because the exponent is 4. Okay, now what? What else do I need to drop down? Okay, keep going. You're doing a good job. Now what?
And then 7 times 1 equals 7.
Okay.
And then you add
6 zeros, because if I count, there's 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. And then I go back in and add my commas. Good job. Colby, help me on the next one. Why did I say slow down on this one and be careful?
Because there's that 0 exponent.
Yeah, what does it mean if I have 0 tens?
It's
Anything to the 0 power is
0.
not 0.
1.
1. So when we see 10 to the 0, we just write down a 1. It still follows that rule. A power of 10 is a 1, and the exponent tells us how many zeros I need to add. How many zeros do I need to add? 0. So it's just 30 times 1, which is 30, but that one gets people. Drake, help me with the last one.
10 times 3 would equal
Be careful, it's not 10 times 3, it's 10 to the 3rd power.
to the 3rd power would equal 100.
Hold on, it's a 1 with how many
Oh,
zeros?
I was looking at 2. Would it equal 1,000?
1,000, because it's a 1 with 3 zeros. Okay.
600 would equal 600,000.
Okay, so I have 6 times 1 is 6, and I add 5 zeros. So, is the math part of this hard? No. If you mess up, you will make a goofy error. You will say like 1 times 1 times 1 is 3. Okay? Or you will put too many zeros or not enough zeros. Does that change the value? If I owe Tyson $1,000 and I give him 100 and say, oh, I just forgot a 0. Does that matter? Yes. Okay, so even though it doesn't, like it's just one number and it's a 0, which is nothing, when you take off that 0, it makes a huge difference in the answer. Okay? Your homework is in front of you. It says 2.4 multiplication patterns worksheet. What do you think is on the back side? More problems. Can anybody forget that? No. There are 18 questions. You only have a few minutes, but I guarantee you can get a lot of the top done if you stay focused. Okay, so I want you to work until I dismiss you in about 3 or 4 minutes.